Colour adds beauty to our world, and light enables us to see all the wonders around us. We also use our knowledge of light in technology to take photographs and videos in lasers and in optic fibres. This movie is an introduction to light. What makes it, how does it travel, and its colours. We also discuss why the sky looks blue and the sun looks yellow. Before we begin, please remember to subscribe to my channel and hit the bell. Also, check out my website, www.learnscience.coza. Besides many free movies and quizzes you'll find there, you'll also be able to order a copy of the poster that we use in this movie. Download an interactive PDF of a gap-fill version of this poster from the link below. Fill it in to help you learn more effectively from the movie. You can order the full bare bones workbook in interactive PDF format or in printed format on the Learn Science webpage. Go to the Orders Bare Bones page. So, what is light and where does it come from and how does it travel? And what is colour? Some objects can give off light and other objects can't. The correct term for giving off light is emitting light. Those objects which can emit light are called luminous objects. The sun is a luminous object, so is a shining light bulb. In another movie, we'll focus on objects which aren't luminous. Light travels away from a luminous object as waves, which we call radiation. Now you know what water waves look like. Of course you can't see something like water waves travelling out from a luminous object, can you? That's because light waves are very tiny waves, and so we can't see them like we can see water waves. But let's use this simulation to help us imagine what they would look like if we could see them. Here we have a red laser, which is also a luminous object. We switch it on, and then it emits red light. Let's change our view on the simulation to help us imagine what the waves of red light are like. Now let's change the laser's colour and make it emit blue light. What do you notice about how the waves compare for blue and red light? Can you see that the blue light's waves are shorter? We say blue light has a shorter wavelength. Red light has a longer wavelength. And that's what makes the different colours of light appear different. Another way to describe these different waves is by their frequency. Frequency means how many per time. How many waves pass a point in a second. Can you see that because the blue waves are shorter, more of them pass a point in a second? Blue waves have a high frequency, and because the red waves are longer, fewer of them pass a point in a second. So red waves have a long wavelength but a low frequency. Blue waves have a short wavelength and a high frequency. Waves of light, called radiation, travel in straight lines away from the luminous object. How quickly does this radiation travel? Well, it depends what the light is travelling through. Let's think about sunlight. After the sun has emitted sunlight, that light travels through outer space. What is outer space made of? Nothing. Empty space, a vacuum. Light travels its maximum speed through a vacuum. What is that speed? 300,000 kilometers per second. We give that speed a special symbol as a quick way to refer to it, and that symbol is c. You might have heard of Einstein's famous equation E equals mc squared. The c in that equation refers to the 300,000 kilometers per second, the speed of light through a vacuum. C is very, very fast. It takes 8 minutes 20 seconds for sunlight to travel from the sun to Earth. When sunlight travels through the Earth's atmosphere, it's no longer traveling through a vacuum. Now it's traveling through air. Light travels through air only very slightly slower than through a vacuum. The difference is so little that we ignore it and we say that light travels through air also at sea, 300,000 kilometers per second. What color is sunlight? You might answer that it's yellow because the sun looks yellow. Actually, sunlight is white. I'll explain why the sun looks yellow in a moment, but first, what happens if we let white light shine through a triangular perspex prism like this one? We get something that looks like a rainbow. We call it a spectrum of colors, or the visible spectrum. How does that happen? Actually, that white sunlight consists of many colors, which together look white to our eyes. The prism spreads the different colors apart so that we can see them separate from one another. We say the prism disperses the light so that we can see the 7 colors of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. Roig Biv. Why can the prism disperse the colors like that? Because light of different wavelengths, and so of different colors, travel at different speeds through the perspex, and that spreads them out. You know that often after rain, we see a rainbow in the sky. How does that form? The raindrops in the air bend the light, they refract the light, and they spread it out. They disperse it into its 7 colors. Next time you see a rainbow, notice how the colors follow the Roig Biv order. Red is next to orange, which is next to yellow, then green, blue, indigo, and last, violet. I said I'd explain why the sun looks yellow. At the same time, I'll explain why the sky looks blue. Remember, actually sunlight is white, and white light is actually made of these 7 colors altogether. Now, as this white light travels through the air, the high-frequency, short-wavelength end of the spectrum gets scattered easily by the air. In other words, the blue, indigo, and violet parts of the white light get scattered in all directions, and so they come to our eyes from all directions as we look up into the sky, making the sky look blue. What about the light that doesn't get scattered but rather reaches us straight from the sun? Without the blue of the spectrum, the rest looks yellowish, so we think that the sun looks yellow. Let's quickly recap. Luminous objects emit light. Light is transferred by waves called radiation. Radiation travels in straight lines at 300,000 kilometers per second through a vacuum, a speed that we refer to as c. When light passes through a prism or a raindrop, it may be bent, refracted, and spread out, dispersed, to separate out into the 7 colors of the visible spectrum, which we remember by the acronym Roig Biv. Red light has the longest wavelength and lowest frequency, and violet light has the shortest wavelength and greatest frequency.